object stays in motion unless acted on by a greater force.
Okay, an outside force or a great
Outside force.
unbalanced force possibly. Okay, what else?
To every action, there's a reaction.
Okay, and does anybody remember? Now that's two of them. Okay, so that's the first law of motion. Everything stays in motion or at rest until acted upon by an outside force or an unbalanced force. The other one is for every action, there's an equal and opposite reaction. What's the third one? Sam?
Whatever goes up must come down.
Whatever goes up must come down. I didn't know that was one of Newton's laws. I think that's the idea of gravity. Okay, who can tell me what the last law is? Nobody, huh? Interesting. Well, maybe today, before we leave, you'll be able to come up with that. Hannah?
Is it like inertia?
Inertia is the one that's the first law of motion. Okay, so anyway, when I was a student teacher, many moons ago, Ronnie, thank you, okay, it was about 6 years ago, I was a student teacher, and I got to teach physical science. It was before I taught, didn't we learn our lesson about tilting the chair this morning, Anthony? Thank you. All right. One thing I was able to do was do lots of demonstrations in physical science because it allows for great opportunities to do that. Now, one thing I used to do whenever I would do this as a student teacher is I would set up my experiment like so. Okay, but I would always use a hard-boiled egg. Okay. Now, I didn't have time to boil these eggs this morning, and Mrs. Chimo needs 4 eggs for a recipe that she's making. All right, for this weekend, she's making some desserts. She needs 4 eggs. Well, I took the eggs out of the house, brought them to school today because I didn't have time to go by the store and spend the school's money on it. All right, I didn't have time to hard boil these eggs, which is a good thing because she's going to need them tonight. Okay, so I'm kind of doing something a little bit risky here today. All right, I'm going to try to perform this demonstration for you. Newton's laws of motion, at least 2 of them come into play here. As a matter of fact, I'm not sure if the third one does or not. Maybe you guys can help me answer that question when we leave class today. So, with that being said, do you guys think I can get this egg into that container with this broom without breaking the egg? No? Yes? How can I do it? Who wants to tell me how I can do it? You got an idea there, Ronald? Yeah, I can't. I don't want to put my hands on the tray. I'm not going to touch the setup with my hands at all. All I can touch it with is the broom. Yeah.
You're going to hit it quickly so it falls straight?
I'm going to hit it quickly so it falls straight.
Ah!
You think I can do that?
No.
But now, how would it fall straight if the pan here has edges that are raised up? That's something to think about. All right. Well, anyway, let's give it a shot. Okay. Let's give it a shot. We'll see what happens. And then I got a couple questions for you guys to try to answer. All right, ready? Okay, so if I take this bag.
Oh, I shook.
I was a little bit worried about that. Mrs. Chimo's going to be able to use that egg now, I hope. So
I was correct. Thank you very much.
It's got a little bit of a crack in it.
I was correct.
Get up, Bo.
I've got a couple questions for you though. I'd like for you guys to be able to answer. So, first of all, what made the egg? I'm going to need you to raise your hand. I'm going to need you to raise your hand. What made the egg fall directly in the glass? What made the egg fall directly in the glass? Tiffany?
The thing that it was on hit the pan and it fell.
Okay.
Hit
the pan and it fell.
The pan went faster than the egg because the egg is heavier than the pan.
Okay. We're getting there. We got some good ideas. That's going to get us started, Tiffany. Great idea. Hannah?
Gravity.
Gravity. How did gravity get the egg into the cup? It pushed it down. Okay. Is gravity acting on all this stuff sitting here right now?
Yes.
All right. Are there any other forces acting on this stuff right here, right now? No, there's not. Right? Is that what you're telling me? Okay. So, according to Newton's laws of motion, this thing sitting here is there because of gravity. Where's gravity pulling from? Where's it pulling from? The what?
The center of the earth.
It's pulling from the center of the earth. So shouldn't this go to the center of the earth?
Yeah, towards it.
It's on
It should go towards it. It's on something.
Because gravity is pulling it down.
Okay, yeah.
Because the sun is pulling on it too.
The sun's pulling on it too, so it's keeping it there. Okay. I might agree with that's why the moon is where it's at. Okay. The sun is pulling on this. You know what? You and I are pulling on this right now too, as a matter of fact. Okay. That's one of the main concepts about gravity. Gravity is the force between two objects, all right, that they have pulling on towards one another, and it comes from the center of the object. Okay. So, all two things, all two objects in the world have gravity towards one another. Okay. Now, which is stronger? You or my gravity on this, or the Earth's gravity? Why? Because it's bigger? So do you think that the mass of the objects makes a difference on which one pulls harder? Okay. Which is more massive, the sun or the Earth?
The sun.
The sun is? The Earth is?
The sun.
The sun is way more massive than the Earth. I mean, there is so much more mass in the sun. I wish I knew off the top of my head what the numbers were, because I think you'd be kind of amazed. Okay, but the sun has a lot more mass. So shouldn't the moon just go straight into the sun?
No.
No?
Because Earth's gravity is also pulling on it too, so it keeps it right in place.
All right, so Earth's gravity is pulling on it too. What, is the moon closer to Earth or the sun?
It's closer to the Earth.
It's closer to the Earth. So maybe not only mass has something to do with gravity, but maybe the distance between the objects has to do with gravity as well. Okay, so there's some ideas for us to think about. Why did I put this water in the glass?
So it didn't break the egg?
So it didn't break the egg? All right, how would it stop? How would it keep it from breaking the egg? Yeah, Bo?
Because when it comes down, it like hits and it doesn't go straight.
Okay. It hits and it doesn't go straight.
Less compact.
All right, so there's several different forces that are in act here. What would happen if I used something that didn't have a rim? If I would have used a pan without a rim, let's say a straight plate.
It would break the plate if it was off.
Well, let's say it's a metal plate, just like this, metal pan with no ridges. What do you think would have happened? Connor, what do you think would have happened? You think the same thing would have happened? Okay. All right. Anybody have another idea? Parker?
It's not so metal thing and the egg would go in.
The metal thing and the egg would go in, you think, right? So I'm gonna tend to agree with you there. I don't have a straight metal pan, so I can't demonstrate for you, but that's a really good idea. Okay, so possibly the ridge of this pan was essential in getting this metal thing out of the way so the egg could drop, right?
Yeah.
Okay, so there's one thought, one idea. Why do you think that when I set this up, I was real careful to set the pan over the edge of the table?
Oh, so it would.
So you can hit it with a broom.
So I could hit it with the broom? Yeah, I couldn't hit it with the broom if it was in the middle of the table?
So that.
No, because the broom wouldn't have got there.
Yeah,
The broom wouldn't have got there. Couldn't I just hold it like this and...
Yeah, but
Then you might have hit
it would have hit the
the
egg.
bottle of water.
The egg probably would have gone.
You probably wouldn't have hit the pan.
It
So-
probably would have broke the egg.
It probably would have broke the egg if I would have taken it like this and just...
Yep.
And killed one of us?
Alive.
And killed the cameraman.
Alright, yeah, I missed her on purpose. Next time she won't be
Yeah,
so
whatever.
lucky. So
Look at this.
So there was a
White
purpose...
stuff on the other.
Oh, sorry. Don't worry, it's not asbestos. So there was a purpose behind having that table there. Why did the table stop the broom?
So it didn't hit the egg.
Were there... No, how did it stop the broom?
Oh, the force.
Well, there's a force. The force is going this way, isn't it? That's the way the broom's moving.
Yeah,
Because
it's a solid force.
It's a solid force?
Yeah, and it stops.
Is there a force acting on the broom right now?
Yeah.
Yeah.
Huh? What forces are acting on the broom? What?
The table's pushing against
The table's pushing against it? Do you think it's equal to the amount that I'm pushing on the table? Greater or less than or equal to? Greater or less than or equal to? Raise your hand if you think it's greater force coming from the table to the broom. Raise your hand if you think it's equal to. Raise your hand if you think the broom is exerting a greater force on the table. Okay. there's some great ideas. All right, so we're gonna learn about that today, and later on I'm gonna talk about that a little bit. You can go ahead and shut that.